conditional probability. So this is an important concept that IB loves to use in a lot of their questions. The idea here is we're going to find probability, but we're going to be given a little more information than normal. We're going to be given a condition. So like an example here, what's the probability of selecting a French student that studies French, given that he studies Italian? And that little bit of information changes the whole ballgame. We know the person studies Italian, so now we know that we're selecting from a person in this circle. So how it's still 1 over total, but now our total is going to be just, we know it's Italian. So Italian is all the people that study Italian. So that's 22. And what do we want? We want to find probably that the person studies French. French, given that they study Italian. So again, we know they study Italian, so we're only looking at the circle because we know they study Italian. How many of those people study French? 8. So that's an example of a given that probability, a conditional probability. So we have a formula for solving this, which is just for event A and B, we use a horizontal, we use a notation A line B. The line here is read as given that. Given that B happened. Or as I say here, it represents event A given that B has occurred. So when you see that line, I always do that, that's a given that. So what's the probability of A given that B occurred? And this is from here. It's the intersection of A and B over B. So if you look at my problem over here, we're doing probability of French given that they study Italian. My form would have been probability of French and Italian over probability of the second one, Italian. Right, and then my Italian here is 22. French and Italian would be 8. So you get the exact same answer. So that's the way that formula works. Here you notice it's numbers. That's what I did here. So probability wasn't the right notation. It should have been number. The number of people in both of them over the number of people in Italian. But it actually also works with probability. Like if the problem was, instead of having numbers, gave us like decimals, like probabilities, it would have worked the same way. So that's a given that formula, and we call that conditional probability. It is in the formula sheet, and we will use it a lot. IB likes to add it to like a bunch of questions. So let's do an example real quick. The probability that it is cloudy on a particular day is 0.4. So probability cloudy is 0.4. The probability that is cloudy and rainy, so cloudy and rainy is 0.02. So probability cloudy and rainy is 0.2. Find probability that it will be rainy on a day when it is cloudy. So right here, probably it's rainy on a day that is cloudy. So right, we have information we know. We know it's cloudy. So probability of rainy given that it is cloudy. So just using the formula now, anytime you say a formula like this, A and B and C are just a template. You use it to whatever you want to do it, to whatever you need. So here, this is R given C. So that means everywhere I see an A, it's really just an R. And wherever I see a B, it's really just a C. So my formula is going to be probability of R intersection C over the probability of C. Those are all values I have. This is 0.2 right here, and this is 0.4, which gets me 2 over 4, which gets me 1/2, or 0.5 if you want. Either way is fine. So that's an easy example of how to use it. We'll typically use this with either tree diagrams or Venn diagrams. So let's do the first one here. In the town, 25% of the residents own a cat, 55% own a dog, and 30% do not own either animal. Draw a Venn diagram describing this situation. So we need a Venn diagram. My circle was so bad I didn't like it. There we go. I don't like that. There. Let's do this. There we go. Okay, one side's cats, one side's dog, and this is the universe. Now, if you notice, they gave us percentages or probabilities. The universe, in that case, is always 1. If we're doing probabilities, the universe is always 1. If you have numbers, then it's whatever the number is. But in probabilities, the universe is 1. So 25% own a cat. Now, keep in mind, that's not this thing right here, cat. It's the whole, sorry, it's not this right here is not cats. It's the whole circle is cats. So I always put like 0.25 in here. and 55% own a dog. So dog right here is 0.55. Because again, it's not this portion, it's the whole circle. 30% don't own either. Okay, people that don't like animals, whatever. Anyway, so 30% don't own either, so we have that. So there's our Venn diagram. We generally want to figure out what the interval is first, because that's going to save us everything. Find the probability that a random selected resident owns a cat, given that they own a dog. Okay, so first we have to find the intersection to solve this, because it's a Venn diagram, and you always need to find the intersection. A couple ways to do it. Remember, one way is you set this equal to x, and this side would be 0.55 minus x. This side would be 0.25 minus x. And if you add up everything there, right, so I added up the neither, I added up this portion, I added up the middle, I added up this side, it all equals 1. So that's one way to do it. Other way to do it is to use the combined events formula, where you have probability of A union B equals probability of A plus probability of B minus the intersection. Whereas this is what we're looking for. We have this, and we do have this. Remember, that is not 1, it is the universe minus the neither. So this would be 0.7 if you're doing it that way. It'd be 0.7 minus all that. I'm just going to finish up this because I have it written out. Let's see, these x's will cancel. I get 0.525 plus 0.55, it's 0.8. 0.8 plus 3 is 1.1 minus x equals 1. Do a little math. 0.1 equals x. So x equals 0.1. So now I know that this is 0.1, which makes this 0.55 minus 0.1, which is 0.45. And this would be 0.15. So like that. So now I can solve this Venn diagram. So question B1. Find the probability that a randomly selected resident owns a cat given that they own a dog. So probability cat given that they own a dog. So right, I'm just going to use use the formula, or you can just look at it. So I know that I want the probability of a cat given that they own a dog. So we know they own a dog. So my world is 0.55. What's the odds they own a cat? Well, cat's right here, 0.1. Which would give us 1 over 55. That's not a lot of odds. So that's one way to do it. Other way to do it is just use a formula. Right? If I have this, the formula would be C intersection D over the probability of the second one, D. C intersection D is just 0.1. Probability of D is 0.55. Right? So same answer. I think a lot of times it's a lot easier to just use the formula. Less thinking. So that's the first one. Second one's a little tougher. Does not own a dog given that they own a cat. So B2 does not own a dog. So what that is dog prime given that we know they own a cat. So using the formula, it's probably not dog and cat over probability of cat. So the bottom part's easy. Probability of cat, 0.55, 0.25. That arrow is the bad arrow. I was running out of space, so I went this way. Let's talk about the top part. Not dog and cat. So we just gotta know that. What's not dog, but cat? It's this guy right here. This right here would be not dog, but and cat. Right? So you own a cat, but you don't own a dog. So right there. 0.15. Which we reduce to 15 over 25. It's like that. So that's using given that. Let's do one more. The top shelf in the cupboard contains 3 cans of pumpkin soup, 2 cans of chicken soup. The bottom shelf contains 4 cans of pumpkin soup and 1 can of chicken soup. Luca is twice as likely to take a can from the bottom shelf as he is from the top shelf. Suppose Lucas takes 1 can without looking at the label. Find the probability that it is chicken. It was the top shelf. So this is like a Venn diagram. No, sorry, not a Venn diagram, a tree diagram. So here's the Venn. How do I know it's a Venn diagram? It's because there's like a neither component. It's cat, dog, and there's some overlap, and there's a neither. This is not. This is like choices. You could just take this path at the top shelf, or you take this path at the bottom shelf. That's more of a tree diagram. Which, you guys know, is my favorite thing in the world. So this is him covering his eyes and picking a thing at random. So we could go top shelf or bottom shelf. So we'll go top, bottom. Probably should put T and P. Now he's twice as likely to pick the top shelf as a bottom shelf. No, bottom shelf and top shelf. Twice as likely to pick the bottom shelf as the top shelf. So you have to make that a fraction, a ratio, percentage. So what that is bottom is 2/3, top is 1/3. Right? He's twice as likely to take something from the bottom as he is from the top. So 1/3 and 2/3. Now if we go to the top, what's on top? Top shelf contains 3 cans of pumpkin and 2 cans of chicken. So pumpkin and chicken. Pumpkin would be, we have 5 cans in total. So 3 out of 5 is pumpkin, 2 out of 5 is chicken. On the bottom shelf, 4 cans of pumpkin, 1 can of chicken. So still 5, but 4 out of 5 and 1 out of 5. Like that. And then look at the first question. Find the probability that he randomly selects a chicken. So remember, the way you do this is you all the paths to get a chicken. So you do this, or you go bottom and chicken. So for A, you want chicken. So the way you get chicken is top chicken plus bottom chicken. So it's 1/3 times 2/5 plus 2/3 times 1/5. So I'm going to get 2 out of 15 plus 2 out of 15 to get me 4 out of 30. 15. Ooh, I'm going to do fractions in a second. That was embarrassing. Okay, B. Was taken from the top shelf given that it is a chicken. So probably top shelf given that it's chicken. I might add another problem to this at the end. So top given chicken. So the easiest way to do it, especially with the tree diagram, is to not overthink it, just use a formula. So probability of top and chicken over probability of chicken. So something like this, right? So especially with the Venn diagram, you don't need to use the formula a lot of the time. You can just think about logically. With a tree diagram, just use the formula. So top and chicken. What's top and chicken? Let's do that in orange. That's the path of top and the path of chicken. So the top probability here is literally just top and chicken. So 1/3 times 2/5. And this bottom portion here is probably a chicken. This is classic IB. That's what we did in part A. Probably the chicken was part A. So they want you to use your answer that you just found and put it in for the bottom here. 4/15. Classic IB. So simplify the top, we get 2/15 divided by 4/15. That's a divide sign. So remember, if you want to simplify this, it's just the top divided by the bottom, which means you multiply the reciprocal of the bottom. These reduce, and you get 2/4 or 1/2. So like that. By the way, let's see if I switched it up. What if we went? What's the probability that he picked chicken given that he went to the top shelf? Chicken given top shelf. So if we use the formula, that's chicken and top shelf over top shelf. Alright, so in that case, chicken and top shelf, we already know. T and C. So same thing we did before. 1/3 times 2/5, I think. How about the bottom, top shelf? What is top shelf? Top shelf is literally just this thing right here. Only where you see top shelf is 1/3. So divide this by 1/3. Hey, these cancel out. 2/5. Which makes sense, because all it's saying is this. If you know you went to the top shelf, what's the odds of getting chicken? Well, 2/5. Anyway, that's the lesson.